And a second here. Okay, so let me start out here with just briefly walking through the problem of computer vision and how it can be helpful in building solutions. And in particular, I thought I would just walk through this diagram real quick that talks through some stuff that I've done in my career in film. For a couple decades, I worked at Disney Feature Animation, Sony ImageWorks, Weta Digital, and a lot of these were films that were 3D animated films or motion capture films. And there were pipelines, and the pipelines would have things like, frames inside where you would have 24 frames per second, and each frame is actually just an image. And one way to think about this is that those images could easily go into, for example, some kind of pipeline. So the pipeline could do some image processing, or it could, potentially go through and find objects, or do some kind of compositing. When compositing is when you merge things in together at the same time. And what's interesting is that all this happened when I was in film, before there was cloud computing. But now, when you think about some of the things you can do with cloud computing, which we'll go into today, it's really amazing what you could do. And so this particular example here, which I think I'll just draw through again, would be a really good example of something that you could do in film. So let me actually just recreate this diagram to make it a little bit simpler. That would be the end diagram. But let's say that you were a film studio. Let's say that, in fact, let me just connect my pin here. Let's make a theoretical film studio called Netflix. I know some people that work at Netflix, so that would be a good example. And I don't really know what they do exactly at Netflix in terms of their film pipeline, but let's take a look at how we could potentially design something using cloud computing technology. So we know that the raw ingredient here would be these images. So ingredient, and inside of this we have things like, again, frame by frame. You could have this is frame 1, frame 2, frame 3, frame 4, and then we'll just say this is frame 24. So this would basically be 1 second of a film. So this is our core ingredient, and they probably at some point would have, let's say, some existing pipeline that is very traditional. And a traditional pipeline in film a lot of times there would be a file server that would hold all of your data, and it would be maybe an NFS mount point for everybody, so the artist could share the film files and write code and share that film. And then next up here would be that they would have some kind of a render farm, where the render farm would process all of these images and do things with them. But in the case of the cloud workflow, you could tap everything that they're already doing and hook into some cloud native capabilities. And so let's just use AWS Cloud, for example. AWS Cloud capabilities. One of the things that's interesting about the AWS Cloud is that it has high-level tools. And so one of the high-level tools is the computer vision APIs. So computer vision API. And what this means is that you could take this existing raw ingredient and you could tap into, for example, this data lake that they have. And this data lake that S3 provides, one of the nice things about it is it has this concept of a mostly infinite resources component. So what that means is that the disk I/O is theoretically infinite. The storage is theoretically infinite, and also compute is theoretically infinite by using something like S3. And also, it has 11 nines of reliability. What this means is that, unlike my experience in traditional film studios, Netflix, potentially could take advantage of the true cloud capabilities of something like S3, because S3 doesn't go down, right? I think 11 nines is in the 1 year period, roughly, let's just call that like 2 milliseconds or something, because there's so much redundancy built into it. And so what happens is that those raw ingredients could fit into a bucket. And so after all of your traditional things are happening in the film studio, you could put those files into a bucket here. And then what's great about this is that now you can use the cloud native techniques. So those are we'll call these traditional ingredients. Here we go, traditional. These are traditional film ingredients. And then these are the new breed, right? The new breed of ingredients. So one of the things you could do, for example, would be that you could trigger an event. So you could listen to the events that come out of S3. And those events could be that you're putting the asset inside, right? There we go. So we put this asset inside. The other thing you could do is, once that event has been triggered, you could then set up a Lambda function to process those files. So with AWS Lambda, now every single interaction that comes inside of S3, I could subscribe to the event, and I could do something when this event is actually triggered. And so one of the things that maybe I would do would be that I would do a label detection. And so what the label detection potentially could do is that this label would be something like a record that could go into a asset management system. So here's DynamoDB, and we'll call this the asset management system. This is always a big thing in film studios, is this concept of trying to keep track of what things you've created. And so in DynamoDB, you could have a very simple record where you would have maybe the scene you're working on, and then the actual shot itself, and then the labels. So there could be maybe a chair, and it could also have maybe like a list of labels. Maybe you could have the actor inside of it. And so why would someone do this is that you could essentially passively keep track of all of the stuff that's already happening in the movie, and then use the off-the-shelf capabilities of something like Amazon Recognition, which is a pre-trained computer vision model, and then start categorizing everything as it's created. So then later, you could then build another thing on top. You could index this information potentially, or query it from DynamoDB. So you could also potentially have a search engine as well, Elasticsearch, and the Elasticsearch engine could maybe use this as an index. And so you could either do key value lookups and look at very specific assets in the movie, or do an Elasticsearch as well. that would let people look for things, and you could build tools around this. So that's one of the really powerful things about the cloud environment, is that it also can tap directly into existing workflows, and you can use off-the-shelf computer vision APIs. And let's now talk a little bit about the options that you would have when you're building computer vision solutions. So next, I'm going to talk about abstractions. So this is high level conceptually what we would build today, and I'm going to go in today and build this. But now let's talk about the trade-offs. So with computer vision abstractions here, so we say computer vision abstractions, you have, in a way, the low complexity, and then you have the high complexity, and we'll call this complexity. So low complexity here, and then we'll say high, and then we'll just say maybe medium. So if we go through here, the idea is, when do you solve the computer vision problem, and with what tools do you pick? So low complexity would be API, right? So the advantages of this is that with an API, you can directly map the business problem to a solution. So that's really what you get when you use an API, is you're mapping the business problem to an actual solution. So in the case of the Netflix example, you could say, look, I just want to get the labels of my data, and I want to put that into a database, and then I also want to create a search engine in front of it. So that's what I'm focused on. The second one here would be, in a medium sense, would be something that's more using like a hybrid approach, where potentially you could use something like transfer learning. And so with transfer learning, maybe the model is mostly created for you, and then what you're doing is you're like copying copy solution that was created by experts, and then this could be an interesting approach. And then you have the high complexity, which would be, do it from scratch. And why would you use this one? Well, this one would be, maybe existing approaches don't work. Existing high-level tools don't work. But it's important to be thoughtful about how you do this. Is most of the time what people care about, especially in the corporate world. In academics, I think people care more about doing it all from scratch and reinventing the wheel, because you get research papers and you get prestige. But in the real world, in business, most of the time people are focused on the business problem and how to solve it with the least amount of difficulty and make it maintainable. And with this, the API, often this is the best approach for a business. Or if the API is not good enough, or you need to do something customized, then maybe you would go to the next layer and you would use transfer learning. Take some existing pre-trained model, change the last layer, train it again, and then use it. Probably the first place you shouldn't start is to just do it all from scratch. Especially in the case of, that hypothetical situation, as someone hires you and pays you, $500,000 a year to work at Netflix. And then you go inside of Netflix and they say, okay, we want you to build a solution that automatically does label detection and puts it into a database and a search engine. If you spent all your time reinventing poorly the label connection, instead of actually building the solution, according to the Netflix culture, they would fire you, right? Because you're not a high performer. I think it's just very, very important to think about that. So let's now walk through what I'm going to build, and I'll show you the diagram of what that is. So next step here, we've got this. So what we're going to build is something that uses Cloud9. So we'll go through here, and Cloud9 is a cloud-based development environment, and so it's we'll just call this a cloud IDE. This really does appear to be the future of a lot of software development now, is that why not use the environment that's built into the location that you're working in. And so why would you do this? Well, if we just make this a giant cloud here, the Cloud9 environment is in AWS. And so the advantage here is that if I talk back and forth to, let's say, S3, that the bandwidth is very fast, right? And so we have low latency because I'm inside of the environment that I'm working in. So bandwidth issues go away. We also have deep integration with the tools as well. So the other thing about the cloud environment is when you're developing with something like Cloud9 is it's as a tight feedback loop. So this feedback loop is very, very important. And the other thing is that I can also build out Lambda functions inside of Cloud9 easily. So it works very well with the AWS Lambda Python code. So if I want to write a simple Python function here that does a detection of labels, I can prototype that out easily. We'll just make detect return result. This is our pseudocode here. I can build this out here, and then I can hook it into an event like this. There we go. So in a nutshell, the ideal location to build some kind of a computer vision prototype here would be to use Cloud9. So that's what I'm going to do next is I'm going to go to Cloud9 here, and I'm going to create a new environment. So I'll go to AWS and say, type in Cloud9. I'll go ahead and create a new environment, and we'll call this one Computer Vision API. That say this is an environment for computer vision. All right, and some of the options you have when you first start out with Cloud9, and I'll just talk through these real quick, is that I would just leave everything default. For most students, for most people experimenting, the defaults are great. You can use the free tier if you use the micro instance, and it's actually good enough, the free tier for most things. Now, if you are going to do like heavy computational tasks, it's also great as well, because I can select a very large machine where I could rent. I haven't had necessarily the use case for this yet, but it's comforting to know that if I ever needed 384 gigs of RAM and 96 CPUs, it would take me a second. Boom. I would spin it up, use it for 10 minutes, and then shut it down again and only be charged on the minute for those 10 minutes. So it is actually a very powerful potential setup. But most of the time, the micro is good enough for me. And then also Amazon Linux would be my recommendation, is just, again, keep it the defaults, keep it simple. That's where the majority of services run on Amazon, is the Amazon flavor of Linux, which is essentially Red Hat Linux, but slightly tweaked. And then also I would leave this default as well, which is after 30 minutes, let it auto time out. And the reason for this is so that you don't get a huge bill in the future and get surprised with like, oh, wow, I'm I have like a massive, bill from leaving the services running. So that's one of the key advantages actually of Cloud9 as well, is that it automatically will keep track of these or timeout. Basically, it'll automatically time out this for you, and you don't necessarily have to worry about turning it off or on. So while that's spinning up for a second, let me also open up another terminal here and go to AWS again and show you the recognition API. So before I automate things, I will typically just use the service first to make sure I understand it. And so Amazon Recognition is a deep learning based visual analysis service. They're constantly making it better behind the scenes, and it has many different features. So you could do custom labels, for example, is a new feature here. You could upload your own labels and then use that to actually train your model. So basically it's a ability to automatically label things where you control it. The other things that it can do is it can do object and scene detection, which is the thing that I'm going to use here. Is for example, if I wanted to, let's find LeBron James. He's in the news a lot. Let's find him. Let's see here. This looks. There we go. Let's take something a little bit more useful here. Let's grab LeBron doing. There we go. This looks like a good picture. We'll save this, and I'm going to call this LeBron Lakers. So if I just go here and I want to upload this image, I can get all of this label detection from here. So we see it's a human, it's a person, sports, team sport, and I can even see what the response would look like as well. So inside of my response, it essentially is making an API call for me and showing me what the payload would look like. Additionally, I also can upload celebrity recognition as well, right? So I can go through here and I can find celebrity recognition. For some reason, it doesn't know about LeBron James, which is surprising. But in a nutshell, I think these are all good ways to explore the APIs. Just go through, first get anything to work. Like if you can't get it to work inside of the browser with your data, it's not going to work when you're writing code. Another one, right, is facial analysis. Let's see if we can see if LeBron is happy here in this picture. Looks like he's not smiling. He's in game mode. He wants to win, right? So now that I've got that working, let me show you the second thing that I would do, which is that I would look at the Boto3 API. So Boto3 is the main SDK that you would use to interface with the Amazon API. And what's nice about Boto3 is that you can see it has literally every component of AWS here is included. So it's extensive. For example, the stuff I was just working on is called recognition. And with recognition, it would be right here. I can just click on it and then find all of the results. And what you'll also notice is that there are additional calls or methods that are available that don't show up in the console. And here's an example where I could compare faces. I could again detect labels, which is the one we're going to use. I can detect text, and it will come back as a key value pair here. It'll say the name of the label that is detected, and then what's the probability or the confidence that it's that actual label. So again, I can just very easily go through here and figure out what the syntax is. And we can see that the syntax, what it wants is, I think it's going to be about 3 lines of code. It's going to say import Boto3, created a instance of the recognition API, and then put in the path where that actual image lives inside of S3. So to do that, what I'm going to do is go to this AWS Cloud9 environment and start building it step by step. So let me give you a brief introduction to this Cloud9 environment here. So the thing that I would start out with in terms of an introduction is first show you that it's got Python 3 installed. There we go. So it's got Python 3.6. So that's the default Python. And it also has an editor built in as well. So if I wanted to, for example, maybe start building some code from scratch, what I would typically do is first create a Git repository. So let's go ahead and do that. Let's call this Film Studio Computer Vision, and here we go. This is an example of what a film studio could do. All right, I'm going to make a README file, and then I like to put in a git ignore that ignores irritating things like .pyc files, and so by adding the Python git ignore, it'll do that. Okay, let's go ahead and click creating repository here. All right, and then what I'll do next is I'll click on code and I'll swap over to use SSH. The reason between using HTTPS or SSH is SSH, I can actually create a SSH key and then copy the SSH key to GitHub, and then I have bidirectional communication that's encrypted, and I don't have to type in a password. So this is, I think, the default way that I would recommend setting this up. Okay, so we got that. So I'm going to go here, and I'm going to do a git clone. So we'll go through here, and we'll say git clone like that. Now, there is going to be a problem, and I'll fix it. Uh-oh, I can't connect because I don't have SSH key set up. So let's go ahead and set that up. Fortunately, it has, let me make this a little bit bigger. It's good enough. So SSH keygen -t RSA. So that makes the blank SSH key. I just find the public key, which is the one I want to share with GitHub, and I can cat it out. So you could put this on the internet, doesn't matter. This is the key that we want to share to the public. So we'll go here, and then I'll go to my GitHub account here and click on my name. So I'll just click on my name here, and I'll go to settings, and then I'll go to SSH and GPG keys, and we'll say, Cloud9 demo 81. There we go. Perfect. SSH key. Great. Okay, so now that that's set up, if I go back here to this repo, I should be able to do bidirectional communication if I do a clone now. So let's see if this works. There we go. So I've got access to it. And then what I typically do when I first start building code against this is I like to do a scaffold in my project. And so let me show you what that means. So if I go into Film Studio, there's a series of steps that I would typically do. So step one is I would create a Python virtual environment. So let's go ahead and do this, Python 3-m -v tilde, and we'll just call this Film Studio. This, and notice I put it into my home directory as an invisible file because I want to hide it, but I don't. And all a virtual environment does is just isolate the Python and the libraries you're using so they don't conflict with other people or other projects on your system. There we go. So we created this virtual environment. I'm going to source it here, .film studio. All right. And then now that I've got this thing sourced here, now I can start to build out the scaffolding. And the scaffolding that I would recommend would be, well, one, I can collapse this down and I can see what's inside of here is I would create a makefile first. So I'd say makefile. And a makefile, the reason why I like to use them is it makes it easy to create a recipe of different things like linting my code, testing my code. And then I would also create a requirements file. And maybe like my application file. And so because we're going to first build out a kind of a hello world application, maybe what I'll do is I'll just call this hello detect. So I'll call this hello detect. That looks good. All right, so I've got make file, requirements file, hello detect file. That looks pretty good. Now let me double click on this make file, and you can see it pops it up into the editor. So this is the other great thing about this environment is that I actually can edit the code inside of the AWS cloud, and I don't have to manage anything. I don't have to worry about my computer, not having enough resources or anything. This is running in a browser. What I would recommend with a makefile, well, actually, not just recommend, it's required, is you want to change this from spaces to tabs. And makefiles want to have tabs, or it's not good. So the first thing I would do is I would create an installation step here. So I actually have some examples here because I'm lazy, and I'll go to, I think, GitHub Actions here and just show a makefile. I'll just copy some of this. So I typically do something like this. I'll have a pip install upgrade pip section. So let's go ahead and do that. Let's just put this in there, and then I'll just swap this into this section. So what this step does is abstracts some of the complexity with the pip command, which is kind of irritating to have to deal with. And for now, let's just stick with this. And I can go to my requirements file, and I know that I really only need two things probably for now, is PyLint, which will lint my code, and then also Boto3, which will let us talk to their API. So I'm going to go to PyLint here, and then Boto3. Perfect. And now I can do the make install, and this gets things cooking to start with. So we'll go ahead and say make install. Okay, that looks good. So notice how even before I start writing application code, I like to set up this scaffolding. And what I would also probably do is go to this file here and at least get something, just a little bit of it working. So maybe like import Boto3, and then in fact, maybe I just put like kind of a boilerplate something, and I say, I think it would be, detect like this, and maybe this would take the bucket and the name or something like that, and then I could say, recognition is equal to Boto3 dot. In fact, I have this code. Why not be lazy again and use some of my other examples here? So I already have, I think, an example open. Yeah, here it is. So I'm going to look at this. Let's just copy what's useful out of here. Okay, I'll just make this part the start, and I'll put in this API call here like that, and then I'll just log that I have a bucket just to get the initial build process working. So we'll just say print this is the bucket, and then I'll do this. I'll put the bucket variable and the name. I'll put this, there we go. So that looks like a pretty decent start. It looks like that would work. And I could even say foo bar, right? Just a little kind of basic test here. And now if I run this, it should just print this out. So if I just say Python hello detect, okay. And now what I can do as well is create the lint process. So this just does basic syntax checking. So again, I can copy this. I had a lint here that would be a good makefile command. So go to my makefile, add a lint section. There we go, and we'll call this hello detects. All right, and this looks pretty good. This hello detect here, and why don't I say make lints? Unused variable recognition. So yeah, so in this case, because I'm not using this variable, it's complaining, which is a good complaint, right? So maybe for now, so that lint is working, what I can do is I'll comment those 2 lines out, and then we'll call make lint. There we go. So things are working. I got the basic scaffolding set up. So now I can start to check in this code. So I would do this next. I would say get status, check this in. All right, this looks good. Commit this, set up initial code for computer vision. And then it's going to give me these warnings. First time you configure a Git repository locally, you'll have to just either create a config file or just follow the instructions. I'll follow the instructions. Here we go. And then I'll just put in my email here. This. Okay. And then I will amend the commit. There we go. And I will save this, write it out, and then I will exit. All right. So now if I push this, I think this would show up in the repository. Let's say git push. Okay, great. So this should show up here. Perfect. And then so now that I got that set up, the next thing that I would set up is I would automatically lint my code every time I push changes. And I think this is something that's easy to forget about. You get focused on building computer vision APIs and fancy things, but why would you not automatically check the quality of your code if you can't? So here's what we're going to do next here is I'm going to click on actions, and I'm going to just set up a workflow for myself. And what's nice about GitHub Actions, I think this is probably the best continuous integration tool available right now because it's integrated into GitHub, and it's really simple. I'm going to just delete all this because I already have an example one, and I'm going to go back to my other GitHub Actions test here. I'm going to copy this workflow. So you can put anything in here. This is just essentially a series of steps that your code will run every single time you do a check-in. So it's for automation. So I'm going to go through here and just use this as an example. And this is a pretty good example for us. So let's go to here and paste this in. And I'll just tweak it a little bit. So this is a Python application test with GitHub Actions. Now I want to do Python 3.6 because of the fact that the Lambda environment uses Python 3.6, and then I'll say Python version, Python 3.6, and then I want to do the installation and I want to do the lint. For now, the test or the format, we can just ignore that for now. We can do that later. But this is, I think, a good start. I would recommend this every project you set up. Why not? It will just save you a lot of time because it'll find errors. So we'll call this initial GitHub Actions. Right, so this works, and then this will trigger a build, and the build will show up in Actions. Here we go. Perfect. And there we go. Initial GitHub Actions. Run actions setup Python 3.6. Install dependencies. Lint with pylints. There we go. So we know that this thing is successful, right? It's automatically checking my code. So this is a huge win for me because, especially if I'm working with other people, is that they can be assured that I'm not checking a bunch of garbage. Okay, so this is really the table stakes to get the project working. So now let's actually do it. Let's actually build it. So the next thing that I would do would be that I would go to S3 and create a bucket. I think I might have so many buckets that I might have to delete an old bucket, but sure. How about autopilot? That looks like a bucket to delete. I'll just delete this one. Sure, let's delete this bucket, and then I'm going to create a new one. Here we go, confirm. Okay, so now that I created some old bucket, I have room to create a new bucket. So I'm going to create a bucket from scratch, and we'll call this Netflix Film Studio, right? And now I'm going to say next, just leave it all the defaults. And now that I've got that bucket, what I would do is put in my image that I want to do the detection on. So I'm going to upload that LeBron James file inside of here. So here we go, LeBron James Laker. Perfect. Okay, so this thing is uploaded. There we go, LeBron James Laker. Now that I've got this, I pretty much have everything I need in order to build this computer vision API. So what I would probably do next is I would play around with interactively building it, or I would build it with a command line tool. I think in this case, probably just a script at first, then a command line tool is probably the way to go. So let's do that. So the next step would be that I can fill out things according to the API. So we know if I go back here, it needs to look something like this. And I guess I could even copy this if I was lazy, just kind of use this as a sketch. And so let's comment this out because I want to, or uncomment this because I want to start using this now. And I'm going to paste this in. That looks pretty good. And so we know that I think the only things that are really required here would be the bucket. So I can say that the bucket will be passed in, and the name would be passed in as well. And then the version, I don't think we need that. I think that's it. I think that's all. That's the minimum viable product here would be this. And then I think we would remove this comma. So that closes that bracket. And let's just double check that this is undefined variable client. Oh yeah, so we'll change this to client. There we go. Looks good. And I think that the formatting, maybe make it a little bit more clean. That looks pretty good. Now, one thing I guess I will show you that is kind of neat is that there is this tool called Python Black, which I do kind of like. And let me just install this. And so if I say make install, instead of just messing around all the time with like exactly how to indent things, I could just say black, and this would reformat it and just make it clean for me. And so there we go. You can see like it makes it like look a little more pleasant. Okay, great. That looks good. And Now, what do we want to do with this response? I think for now, we could return the response. Here we go. And then the other thing that we would do is I could say maybe print it, right? Because we would want to see what's the result of this. Okay, so now that I've got this inside, I would need to put in the bucket. And this is probably a good way to do it, is say bucket is equal to Netflix Film Studio. And then the name of the image would be the that LeBron James image. And I think it was called, let me just double check the name. Yeah, it's this. If I just click this, just get the exact name. Why guess when I can be sure? There we go. And that looks good. So it looks like I have a hello world pipeline here working. So let's go ahead and run this. So let's say Python hello. There we go. So I actually have some full round trip computer vision code working. So the next step for me typically would be, say, make lints. Let's just make sure that this still works. Okay, good. The code is still syntactically correct. And so let's now commit this. So git status. Okay, well, I have a change to the hello file, and I added the Python black code inside as well. So we'll say git add here, commit this, adding computer vision working example. Perfect. Okay. So, I need to do a poll because if you remember, use the GitHub actions, and so the GitHub actions will get pulled down here. There we go. So now I can do a git push. And we can see again, if we go back to that repo, that this should trigger the actions again. There we go. And it will run through it again, make sure that our code works. So we've got a pretty good setup here. Our first day at Netflix, we're already solving problems. Hopefully we don't get fired. I know that they fire people all the time there. So we can hopefully make them happy. Okay, next up, what I would do is build a command line tool. So let's start to convert this into a command line tool. I like the click library personally because I feel like it takes this, which is a function, and maps it into a service or a tool very easily. So next up, I would use the click command line tool framework. So I'm going to go here, add in click, and then I can go through and map this out. Now, there are a couple different techniques that we could use as well. We could just leave this as like a library, which I think would be a good idea because if I wanted to use it as a library, that could be one way to do it. Or I could also just make it a hybrid tool where it's a command line tool and it's also a library at the same time. I think we're okay with making it a hybrid. So we'll go through here and we'll say import click. And then next up here, I would have to build a scaffolding around this. So a couple of things that I'm going to do to change this is that click at the bottom, when you build a click command line tool, it wants a if under name block. And this is a convention. If under name is equal to, in Python, and all this means is that if I run this as a script, run this block of code, otherwise let someone import it. So it lets someone build both a script and a library at the same time. And so we'll call this maybe detect here. Or actually we'll call this maybe CLI. Because I think what I'll do to make this simpler is I'll leave this here so that I can import it in some other code potentially. Okay, we've got CLI, and then I'll say def CLI, and then this will take a bucket and a name. And maybe even I could add a color to make it fancy. And then what I'm going to do here is I'm going to copy some existing click code that I built before. So let's see here. I have so many click examples. Why do it again? Let's see here. Let me find something. This looks promising. What's in here? Hello, is this a script? Yeah, here we go. So I have some boilerplate click stuff that I built before here. So I'm just going to copy some of this. I'm just going to go through here and grab some of my other code and throw this on top. And so I'll explain what these steps are. So the way click works is that it engulfs a function and puts command line options on top of it. And all I need to do now is put in a help message first and say, this is a computer vision application, application. That looks good. And then for the prompt, or for this, we will remove the prompt and just say that this is, or no, let's leave the prompt. Let's say I need the image file name. Need image file name. File. There we go. So this will be the bucket itself. And then the color, that's good. We can just leave that. Let's go through this and we'll put in the bucket here, which is bucket. I need the bucket name. So there's help and prompt. Prompt will just tell you a prompt, and then help will be what it shows when you do the flag. So we'll say bucket. So this looks pretty good. Now all I need to do is wire this stuff together. So we know that the main function that does all the work is this detect function. So this will be the results would be here, and we would pass in this into this detect function, and it would take in, we know it takes bucket and it takes name. That's it. There we go. Now that I've got the result, what I could do is just say click.echo, and I'm going to go back to this example here because I have like a style example like this. I'm going to go here and just use the style example. And what this will do is it will echo the results. Say, this is your results. These are your labels. And we will put in the result here. And then for the color, this would be the color that would be passed in. So basically it's going to print out the results in some color that I pick. So I think this will work. This looks pretty good. So what I will do is first I'm going to reformat this with the black tool to make it a little bit nicer. So in fact, I'm very lazy. So because I did this more than once, I don't want to do it again. And I'm just going to say black hello detects.py. I want to keep things simple. So I'll just say make format. There we go. All right, it formatted it for me. And it looks like it kept everything the way it is. Okay. And now I can go through here and say hello or Python hello detects. And it says I need the image file name. So I left this here because I knew I would probably need these variables here. So let's see. The image file name would be LeBron Lakers.jpg. Okay, I need the bucket name. The bucket would be Netflix Film Studio. Perfect. I need your color. How about blue? Is the bucket. It prints it out blue. So now I've got an even better tool. So I'm even less likely to get fired from Netflix. I want to keep being an A player because I know they every day it's like the Princess Bride story is like most likely tomorrow you will die. So it's that sword of Damocles that I'm avoiding at Netflix. So I got this, and I'm going to say git status, and there we go. Commit this, adding working command line tool. And in fact, we didn't lint this, but let's see what happens when we go back to our GitHub Actions. It's also gonna lint our new changes. Now I think it will fail because you have to tell the lint tool to ignore some of the things that Click does. Because Click is super fancy and has all these meta programming things that the lint tool doesn't completely understand. And so there we go. So one of the things that happens is that that this particular error here will show up in our lint tool. So, and this is only because PyLint itself doesn't know about Click exactly. So the way that I typically will handle this is I know that the code is working, is I will, in my makefile here, I'll just also ignore that particular warning. And then I will say make lints and see if it works. There we go. So that works. So now I can fix that and say git status, git add, makefile. Here we go, adding finished lint. All right, this is looking very good here. And now that I've got this whole round trip set up here, let me just show in a visual what we've created here, because I think it is important to show this ecosystem and why it's so useful and how it could again prevent you from getting fired from your Netflix job. So step one is that I created this Cloud9 environment. Here we go. Cloud9. And then I also build out this scaffold. And the scaffold would be the makefile. It would be the requirements file. And then it would also be makefile requirements file and then my source code. In this case, it was the hello detect. Hello detect. Once I get all that in, then I hook into GitHub. And in GitHub, I enable GitHub Actions. And what happens is that this is a feedback loop now where push changes. Every time I push the change, it is testing. It's testing my code, right? Because we know that quality control feedback is working. Additionally, I build out a command line tool, so a CLI, and that CLI talks to the AWS Recognition API. Recognition. And the AWS Recognition API helps me communicate to the S3 bucket. And the result is these two calls, give me back a label for an image. So we only took, let's say, half an hour or so, and we have complete end-to-end system that's got the DevOps capabilities here built in, and we're doing labeling and computer vision. So this is pretty good, but I think a couple other things could be better. What else could we do to maybe make this more flexible is we could also hook in, maybe build a web service, which we'll do next, and also build a Lambda as well. So I think we have time for both. So the first thing that I would potentially do would be to build out a Flask app next. So let's go ahead and do that. Let's log in here, and let me just log in again. I think let's go to auth here real quick, and save. Okay, so I'm reconnecting to my dashboard here. Computer vision demo. Actually, that doesn't look right. I think it's computer vision API. That's the one I was in. Okay. So now that this thing is working, the next step again that I would do would be to add a Flask component. So let's go ahead and do that. Let's add Flask now and build a very small Flask service. Fortunately, it's pretty easy because of the fact that I have already put this code inside of this layout, and so to build a Flask app, I could just make another file here and call this web.py, and then inside of the web, really it should be pretty simple. It would just be like import Flask. In fact, I can be very lazy and just do a Flask hello world. So Flask hello world. Let's just keep it simple. There we go. This looks pretty good. Let's do this. Actually, I have my own Flask hello world that I'll look at, which has got a little bit more, I think like GCP AutoML. Let's see, this looks like a good one. Let's look at this. Let's just copy some of this stuff in here. Okay, so this looks good. So I'm gonna put in a if under main here like this. That looks good. And then I think the only other thing I need to do is do some basic import here, which I'll do next. So I'll just say that. That looks good. And then the other thing I need to do is make some kind of a function. This looks good. Sure, we'll do something like this. There we go. So we got a route. So pretty close here. So what I'm going to do with this route though is I'm going to call this text, and this is going to take the bucket, and it's going to take the image. So we'll go through here. Let's do this. That looks pretty good. Bucket and or a name. So bucket and the name. So what this will do is essentially what I did before with the command line tool, which we've proven looks like it works. So for now, though, to just get the feedback loop working initially, what I'm going to do is just make sure that this is actually functioning by putting in this return statement that shows me everything that's happening. So, and I think actually logging would be a good idea as well. let's just in case I need to do some logging, let's go ahead and put that in here. Let's do this. Looks good. Okay, so let's see. These are so parameters. Looks pretty good here. This was passed in. Let's make this an F string to make it a little bit cleaner, and maybe say logging info, and put this is the bucket. This is bucket. And then name right here. Here we go. And this is name. Perfect. All right. So what's neat about this is that this particular Flask application should print out what I put inside of this route. Now this as well, I think I would change the name of this route to be detect. Here we go, just like that. And then I would return back maybe the same message as well. I would say just initially here, put this string in. Okay, so let's see if this works. So what I would do is say, double check I've got that in my requirements. I do. So I would say make install. Looks good. And then I would say Python app.py, web.py. And then we see that this is actually running in localhost here. And so what I could do is open up another terminal and then just curl that endpoint locally and see if that works. There we go. Okay, curl. And I would just put in the simulation of what I would do, which is, I think we have these names here, which would be Netflix Film Studio, that, and then I'll put in this image. There we go. Perfect. And let's try this first. Oh, that's right, because I didn't put detect. That's the problem. There we go. Anyway, so you can see that it's printing out back what I put inside of there, right? So I guess to be lazy here, I could probably just wire up the rest of this by importing that detect function. So if I said from, say from hello detects imports detects, I could now get the result. So let's see if we can get this. So we can say result would be to go to this detect function and then go to the bucket and go to the name. There we go. And instead of just me printing that same thing out again, what I'm going to do is I'm just going to return back. I think it would be, in this case, I think I have like a JSONify response from Flask. So we'll say Flask JSONify response should, yeah, I think you just say this. And we'll paste this in here. So we'll import this from Flask JSONify response. You can see Stack Overflow has made programming much easier. It didn't used to be like this. JSONify result. There we go. Okay, and then it restarts this, and then in theory, this would just work. Sure. It's, I don't know what. Anyway, without getting too tricky in here, and because I want to go to the next thing, which is the Flask app, it's probably, let's actually just try this. Let's just try to print this out. Let's do this. Go back to this app. If we can't get this working in 1 second, not a big deal. Anyway, there's something I'm doing. It's probably because I'm passing in the dot name or whatever, and I need to clean it up. Long story short, we could call this inside of some kind of a Flask app. So I'm just going to commit this and put this in git status, or actually go here, stop this, and do this. So git status, git add web. So this at least is a placeholder. We know that we need to clean it up a little bit, but like, let's say the start of a web service. But the really cool thing here that I've done before is to then hook this into Lambda. So we've got a command line tool, we have a Flask app that we need to flesh out a little bit, but then also a command line tool. So how would I build a command line tool here? Well, what I could do is click on this tab here. I'm sorry, a Lambda, and then I would click on this icon that says create a new Lambda function. And what we'll do is we'll call this label it or something like that. And it will go through a wizard that will allow me to build out an event-based Lambda function. For trigger, there will be no triggers because it's going to be based on an event in S3. There we go. And now for role, this is really critical, is that in AWS, I need to have the proper permissions to do this detection. And so I'm going to choose an existing role here where I had some administrative privileges created. There we go. Got this working. So now that I've got this Lambda function built up, let me just show you a really simple hello world Lambda, and why Lambda is kind of interesting is I like to build this one as first up. I would say, I would say if event is Marco, or name is Marco, then return Polo. Return Polo. There we go. That looks, let's see. Oh, it's a string. There we go. Okay, so now that I've got that going, I can actually just go here, right click on it, run it, and I can actually test this thing local here. And I can say, for example, name Polo. It was capital, right? Or no, Marco. Was it capital? We'll see. I'll double check. It was, yeah, capital. So run it again here. There we go. So it's returning back. So I have basically a feedback loop. So I can actually deploy this now and get this working. So let's go ahead and deploy this. I'm going to go now to open up another instance of the console. So right click here, make up another instance, and go to the Lambda. And now with Lambda, what I can do is I can actually test it out in here as well. Here we go. Right, and you see here's my code. Now if I want to test it, I can create a test function, configure test function, and we'll call this Marco. I can do the same thing. I can just test out that this works. So now the question is, why am I doing this? What's the point of all this? Is what we're going to do next, once I verify that this works, is now I'm going to build an automatic computer vision labeling system. And the way I'm going to do this is that, because you can see here, right, this is working, is that I'm going to hook up a trigger, and this trigger will automatically label the data that I built in that detect function earlier. So I'm going to click on trigger. And then from here, I'm going to go through and add in an S3 bucket listener. So I'm going to tell it, listen to this bucket here, which would be the Netflix film studio. There you go. And I want it to listen to everything inside of here. And this Lambda function will print out things to the console every time I put in an image inside of here. So it's pretty close to being done. And so the next thing that I'm going to do to get this working is to put in some boilerplate code that I've got earlier here. So I already have some code here that I think it's this one. Let's look at this Lambda complete end-to-end function. No, so I need to process the events. That's the main thing here that I need to do. So it's not this one. There's here we go, S3 trigger Lambda function. So this is an example of what I would need to do. First, I would need to do the detection, which we already built. And then I would also need to process the events that come in. So this is one of the things that Lambda can do, is it can listen to everything that's happening. And in this case, I'm going to listen to this S3 bucket. So I'm going to basically copy this here, and I'm going to put this into my Lambda function. So I'm going to go like this. I'm going to just paste this in. There we go. And one thing that we will need to do here in this Lambda function, I believe, is install Boto3 if it's not already installed. Although I think Lambda already installs Boto3 by default, so I don't think we'll need that. So I think we could be good. But I'm going to go back to this hello detect function here that remember from earlier, and I'm just going to copy this code, and I'm going to put it inside of this Lambda function. So here we go, like this. And here's the click function, like this. And so if you remember, this will detect the Boto3 code, or detect the labels using the Boto3 recognition. And so all I really need to do is process the events that come in the bucket, and also print them out to standard out here. And so in this one, instead of label function, I'm going to call this detect here, detect. And we know it takes a bucket and it takes a name. In this case, the key would be the name, because this would be the file that's put into the bucket in S3. So let's just double check what this error is. Undefined variable quote plus. So I think I have another piece of code missing here, which is unquote plus. Oh, there we go. So I have this library that I need to import like this. Okay, so this looks pretty good. So I'm going to just go for it and see if this actually works. So I'm going to right click here, and I'm going to deploy this code. And once this deploys, what's interesting about it, well, first let's let it deploy, is that because it's event-based, the way to test it is I actually have to put a file inside of this bucket, and then that bucket will trigger the event. So let's go back to this here, and let's look at this function. Let's look at this, and we'll know it's changed when this refreshes. So I can maybe refresh this, and we should see new code here. Here we go. There we go. So here's my whole Lambda function. So not bad, right? It's only like 25 lines of code, if it works. So in order to trigger this, what I'll need to do is go back to this bucket and put a new image in here. And I think that I do have like a bird on my desktop or something like that. So I'll just add this. There we go, brown J, which is some kind of bird in North America or New Zealand or something. There we go. Added this. So this should have triggered it. Now, how do I know? What I would do is go to monitoring, and we could see the API calls would occur here. And I could also look at the logs in CloudWatch. And once I look at these logs in CloudWatch, this should show me, there we go, there's my brown J, right? So this is the bucket. So we do have end-to-end full round trip working now as well. So we have 3 tools. 2 of them work, one of them doesn't work yet. But I think this shows the power of when you build a function and map it to something, how quickly you can actually build working code. So that what I'll do is I'll check this code in so that other people can see it. So we'll go here, get status. Looks actually like everything is good. And so I don't need to check in that code. But maybe what I'll do is I'll take this Lambda function and we'll say status here. So let's just check this one in as well. And say touch Lambda. And then we'll also just throw this in so other people can see it. There you go. So there's a full working Lambda function, and maybe put a comment at the top here as well. So full event driven Lambda with label detection. There we go. All right, that looks good here. Let's go ahead and check that in. Git status, git add Lambda. So we'll just summarize really quick here. What did we build next? So the final thing that we built was the S3 listener. So the first part was we hooked up a scaffolding. We hooked up GitHub Actions to test our code, linted everything. We built a command line tool. That was phase 1. That was build number 1. Then in number 2, we started to build a Flask app. Got a little stuck. That's a to do. And then in phase 3, we went through and we built out the event-driven Lambda. And this event-driven Lambda, what's powerful about it is that we just listen right here to this S3 bucket, and then it automatically triggers it. So you can see just in right around an hour or so, you can build a lot of code quickly if you focus on the right tools and you focus on mapping a function to a problem. So that's probably the big takeaway here, is mapping a function to a problem, right? To a problem. So